let's talk about how we can remove the backgrounds from an image using the edge detections. In this case, we're going to use the softbox operators. Here, there's the background, and after we apply the softbox operators and we define the mask, we'll be able to separate the foreground objects from the background objects. And in here, it should be blurred, or it can just be black value. To be able to do that, we first import the library, which the request function is to download the image from the internet, using NumPy functions to process the array of images. And there's a lot of functions that is implemented in CV2 which allow us to use the softbox operator, the binary threshold, and more. And now the matplotlib library will allow us to visualize the image. Next one is in the IOT functions. They're gonna be the byte IOT functions, which also help us to download the image. This one's to load the image. Next one, we will specify the URL of the image that we will be working with. We will use the request function and call the get API to get image raw content. We also need to pass from the raw content into byte using the byte IOT and pointing to the content of the response, which contains the raw image. For the image, we need to pass into a NumPy array, which will be useful for further processing. Load of the image using the image open of the byte data. Now we show the image using the matplotlib function. And now we see the burgers with the hand. Our goal is to separate these foreground objects from the background. The next thing is when we're working with gradient or edge detections, we want to transform the image into black and white. So we'll be able to calculate the image intensity. And the first parameters is the image, and we specify that we want to transform from RGB into grayscale image. We want to smooth the image a little bit using the Gaussian blur. And the first parameters is the gray image we just got from the previous step. We also specify the kernel size to be 5, and the standard deviation is 0. Most of the times we want to smooth or blur the image a little bit before we apply any kind of detections, because this image right here, it has a lot of details and it might interfere with our algorithms, so we can blur it a little bit so all of the details doesn't interfere with the model's prediction. Okay, so we plot the grayscale and smooth image. We also need to use the transform this into gray so it looks better. And now the gray image. Now we want to detect the edges or the gradient of the image, so we use the softbox operator and we pass in the smooth image. The next one is the format of the image, so 64-bit and float. We are using first order derivative for the x directions and also first derivative for the y directions, with a kernel size equals to 5. So plot the image like this, change into grade format like this, and we will see the edges of the image over here. A lot of details on also the hand like this, and it will be used as a foreground object. Next one, we want to separate this one using the some threshold value. So if anything's below 50, we'll remove that and we see them as the background. But if it's larger than that, we'll identify them as the foreground object. So the first value that returns from the CV2 threshold function is the threshold, because there are different types of thresholds like adaptive, and it will give you different types of threshold. But in here we're using binary threshold, which asks us to input the threshold at the start, so we don't need to get this value all over again. So just remove that, and now doing some parsing, so the edges are in the right format, and we also get only the positive values from the edges. And now we define our threshold value, which is equal to 50, and the maximum value. Now define the actual thresholding mode that we're going to use, which is binary thresholding. Anything below a certain threshold values is going to be removed. Now we show the binary mask, and we got our mask ready. But now we want to get the actual mask from this one, so we want to combine the two images together, the original image and the mask, so we get the foreground object. We can do that using the CV2 bitwise function like this, and we specify the image twice, and the mask is the binary mask we have just calculated from previous step. And now if we print it, we will have the foreground object. Thanks for following this tutorial.